Hi there, thank you for coming to my presentation. My name's Terry Brown from the School of Mechanical and Mechatronic Engineering at the University of Technology, Sydney, and I'm just going to talk to you today about my reflection on practice as I've taught first year students in mechanical and mechatronic engineering using a design and build project, and looking at that through the lens of motivational theories and looking at the motivation of first year engineering students and the contribution of the design and build project. So the overview of the presentation is that I'll look quickly at the educational background and context, a brief look at motivational theories, or at least the two that I've looked at, the design and build project details, the data from the surveys, both the quantitative and qualitative data, and we'll also look at some student statements and our analysis of those statements, and then summary and conclusions. So the educational background and context. Hands-on design and build projects have been considered to be essential components of practice-based learning for engineers for a long time. This is a particularly favourite quote. It's unrealistic to expect students to design a smoothly operating, profitable machine if they've yet to nail two boards together. And then finally, a third quote which relates more to the motivational side of things. And this quote here is that students are extremely motivated by building something with their own hands, which they designed themselves. So now looking quickly at the motivational theories. So I've looked at two that have informed my learning and teaching design. So firstly, expectancy value theory. And my understanding of this is that motivation comes from a person or a student's expectancy, or the extent to which they expect to succeed in the task that they have to do. The other component is the value of the task to the learner. It's important to note that these two components are essentially multiplicative. So a student may expect to be able to succeed in the learning. They may be able to expect to do the learning activity. They may see it as very easy, but if they don't value that, if they don't see it as relating to their career path, as something that's meaningful to them as a future engineer, then they're not going to be very motivated. Conversely, if they see value in what they're doing, if they can see clearly that, yes, this is something that I see that I might be doing as a future engineer, but they see it as too hard, or they don't expect to succeed at the task, then that will also negatively affect their motivation. The other theory that I've looked at is the self-determination theory. And again, my understanding of that is that when a student experiences conditions that support their autonomy, competence and relatedness, that fosters volition, motivation and engagement, and these result in enhanced performance, which is what we want from our students. We want them to persist in their learning, and we also want them to be creative. In my analysis of the student feedback and student statements, I've looked at these 5 components of motivation. So the project is very quickly to design and build a wind-powered vehicle that travels into the wind using the wind as its only source of energy, and you can see some examples of the wind-powered vehicles and the fan there. This is predominantly first year students, and we have cohorts of approximately 300 in one session and then 100 in second session. Students working in groups of 4 to 5, and they work in a workshop design studio environment. So we've asked the students their perceptions of the impact of the wind-powered vehicle project on the motivation factors, and I've done so by asking them how they perceived the impact, whether it's positive or negative, on these 4 things. So their expectation to succeed in their studies, confidence that they can design a mechanical device, confidence that they can become successful engineers, and their ability to work with other students. Okay, and as we can see, largely positive responses to those. My co-author and I looked at the student statements and tried to identify things that they've said in their statements that related to the 5 motivational factors that I mentioned before. So looking at a couple of student statements, so one that's mostly positive. Achieving great results boosted my confidence and expectation to do well in their studies and also as an engineer. And we can also see a positive experience of relatedness. Now looking at a couple of negative ones. Okay, so here we can see the student thought that the project was too hard, so their expectation to succeed wasn't there. They felt clueless at times and lost, and although they valued the learning task, so they could see that this project would help them to become a better engineer, the fact that they didn't expect to be able to do well and felt like that they weren't competent meant that their motivation was lacking. Okay, so they just sit back and let others do it, and they also gave up. Okay, so the student also noticed that they noted that they wanted the tutor to just show them step by step how to make the project. They were happy to some extent to give up their autonomy, which contrasts with this student who said while they liked the project, they felt that it seemed to steer them towards making a very standard wind power vehicle. Okay, so summary and conclusions. So most of the students had positive experiences of competence and relatedness. The motivation that the students felt went beyond just the project and the subject, and the motivation theories continue to inform my design of teaching and learning activities. Thank you very much.